Welcome to Smart Contracts. My name is Jamilia Grier and I'm going to be your instructor today. So in today's course, we are going to talk about all of the basic components of a smart contract. We're going to delve into the history and the evolution and the use of smart contracts in blockchain technology. We're also going to talk about the technical foundations of smart contracts, what makes it different than legal contracts. And of course, we want to overview and talk in detail about legal implications and regulatory considerations of smart contracts. We'll talk about real-world applications, use cases, and of course, my favorite, ethical considerations and future trends of smart contracts. So here are the learning objectives for this course. First, when you leave this course, you should have a solid understanding of how smart contracts function and their underlying technology. You also should have some insight into the legal implications as to how they're made, the enforcement issues, and of course, dispute resolution. We want to give you practical knowledge in terms of working with smart contracts, not just about their development, but also with auditing them and security best practices. It's also very important to be aware of current regulatory approaches and potential future legal frameworks that can come about related to smart contracts. And as always, one of the most important things for this course is that you walk away with an understanding of use cases, practical implications, and how smart contracts may show up in your work. So let's talk about what smart contracts actually are. Smart contracts, you can think of them as a self-executing instruction that is reflected in the form of a code, and it is directly written into sort of a data package. Okay, these smart contracts are automated, they are transparent, and they are immutable. Do any of these key characteristics sound familiar to you? If you were listening in the first lesson, you would realize that these are from blockchain, right? And so we will talk about the evolution of blockchain and the timing of blockchain with respect to smart contracts. The purpose of smart contracts is to facilitate, verify, or enforce the negotiation or performance of contracts. So you may recall that when we talked about Bitcoin, we talked about the evolution of Bitcoin happening in the 2000s. But you notice that the evolution of smart contracts happened before then. That's because the concept of smart contracts in terms of a self-executing code that can be written into computer code happened in 1994. It wasn't until Bitcoin was introduced till that concept was applied to the use case of Bitcoin and blockchain to bring us to where we are today, where we have Ethereum, which is a protocol or a platform that is able to run smart contracts. And of course, there are many more platforms and protocols that are able to run smart contracts, but Ethereum was the first one. It's important to note that not all blockchains can run smart contracts. And so that's something to be very thoughtful of as you work maybe with a product team or development team, just to ensure that the capability of running smart contracts are either present or not present as they would desire. So what's important to note about execution of smart contracts? Once a smart contract is created, once it is embedded into a protocol or a platform, that smart contract is automatic, meaning that once certain conditions are met, it will execute. It does not need any further human intervention or any further trigger. It only needs the triggers and conditions that are mentioned within the smart contract. It's very different than a traditional contract, which we're probably used to in the legal sense, where, for example, in consideration of buying a house, you may need to put a deposit down. And the deposit will serve as some form of consideration towards the purchase of the house. That's something that you have to do. It is manual. Your action is required. But in a smart contract, there is no additional action that's required to progress the contract. Also with smart contracts, intermediaries are not needed. And that is one of the strengths, and also, quite frankly, one of the controversial things about smart contracts is that it doesn't need a third party to verify. They do not need a third party to assist in the execution. They have minimal or no need for a third party to support or to interfere with the execution of the smart contract, compared once again to our traditional contracts where we use a number of third parties to ensure that performances are done within a contract. You can think of the example of, once again, a mortgage, right? And so within the mortgage, you have your underwriter, you have the bank, you have the loan issuer, and you have the home purchaser. You have so many parties to ensure that the transaction is executed in the way that it's supposed to be, according to the contract. Now, the tricky part about smart contracts is they are written in code. And for that, many people feel a bit unsafe, particularly lawyers or non-technical people may feel as though if the smart contract is written in code, I can't read it. Right. And so there are a number of use cases, which we'll talk about later on in this particular course, about how smart contracts are evolving so that you don't necessarily need to know code to understand what the smart contract will do and how it will be executed. Cost. Smart contracts generally are lower cost than other contracts, legal contracts, the types that we're used to. Smart contracts, once again, the initial cost is within the development, it's within the programming and the creation of the smart contract. There may potentially be other costs relating to what we call gas fees. If you recall, we talked about proof of work in our previous lesson, and typically platforms or protocols that run on consensus mechanisms involving proof of work have gas fees that can be quite high. Outside of those gas fees, though, traditionally smart contracts are much lower cost than other contracts in terms of producing and executing. Now, let's talk about some of the platforms and some of the protocols that use smart contracts. Now, we talked about Ethereum. I briefly mentioned that Ethereum was the first major smart contract platform. And for that, and NFTs were in a boom back in 2020 and 2021. Many of these NFTs were minted or created on Ethereum because NFTs, for the most part, require a smart contract to execute on royalties. And we will talk about that later on in this course. But that's something to remember. Other platforms that use smart contracts, as you can see, Solana, Cardano, Polkadot, and Binance Smart Chain all have capability to run and execute smart contracts. Now, we don't want to get too detailed, but I do want you to know that not all smart contracts are alike. Not all smart contracts are as effective or as complex as others. Some key features may include Turing completedness. Now, the Turing test or the Turing complete test really refers to how complex of a transaction can be performed on this particular mechanism. So when it comes to smart contracts, we measure them in terms of, can this smart contract perform extremely complex transactions if given the adequate amount of resources? And for Ethereum, it certainly is considered by most people to be Turing complete, which means it's able to run very complex transactions within the smart contracts on that particular platform. We also look at state management. What is state management? It's basically the management of data. How is data held and managed within the smart contract? And it has different levels of effectiveness through different blockchains. And then, of course, decentralized execution. Decentralized execution, as you know, means that the execution is not done by any one entity. It's not done by any central entity. It is essentially done spread out across the blockchain or the protocol. Now, if you're working with a product team or you're working with developers, it's important to know that they're going to speak a totally different language than you will. And that's totally fine. What you need to know is that there are some programming languages that are most used when it comes to making smart contracts. And for the most part, most businesses that are blockchain or Web3 savvy, they really do need developers that will know these programming languages to be able to create their product. So Solidity, Viper, Rust, those are all three programming languages for smart contracts that you may hear talked about amongst the product and development team. Key features and functionality. Now let's get into some use cases for smart contracts. Smart contracts are essentially automated and self-executing. That means that they work on logic. So once an event or a trigger occurs, the smart contract will move forward and do the task or exchange the cryptocurrency or whatever it has been programmed to do. It will do it in such a way that it was detailed within the smart contract. These can be time-based requirements, they can be event-based requirements, or they can be condition-based requirements. Let's look at the example of NFTs. And I think NFTs is a great example to use because NFTs are quite common. Most people know that these are either popular in terms of buying and selling and trading. But if you look at the underlying technology of how NFTs work, they essentially run on smart contracts, particularly those that have royalties baked into them. So let's use an example. Let's say I own an NFT. And this NFT is worth $100. I've marked it to be sold at $100. And I'm going to sell this NFT on a platform. That essentially means that when I go ahead and sell this NFT, if there is a smart contract embedded in this NFT, it will execute. Essentially, the smart contract would have to say, when this NFT is sold, please give 10% to, let's say, the person who sold it to me. And so that is called a royalty. And many NFTs have royalties baked into them. Essentially, what a royalty is in the NFT landscape means that whoever has created this NFT, once it is sold in the secondary market, upon each sale, a percentage of that sale price will go back to the original creator of the NFT. So let's look at that example again. Let's say in this example, I am the original creator of the NFT and I sell it to you. And then you sell your NFT to someone else. That means that I would receive 10% every time that NFT is sold, depending on whatever price it is. And so you can see how this can become rather complex. This smart contract needs to follow the NFT in order to be executed properly. This smart contract needs to have my digital wallet address so that it can pay me properly. And it also needs to have the data about how much the transaction is for. All of these data points need to be included in the smart contract. And that is another reason why it's so important that smart contracts are trackable and immutable and decentralized. Code is law. When smart contracts are created by maybe NFT artists, an NFT is created, people have certain expectations about how much that NFT will be sold for. And there has been a lot of discussion in the NFT art space about properly paying artists. Essentially, once a contract is made, a smart contract is made within an NFT, it cannot be changed. So for example, if as the original creator or the original artist of an NFT, I ask for 2% royalties, which means that every time the NFT is sold on the secondary market, 2% would go back to me. But if I want in the future to change that 2% to something else, we can't change that smart contract. Another smart contract would have to be made, and another smart contract would have to be accepted by all subsequent buyers. Therefore, it's extremely important to know that when you're working with product or development teams that are trying to build out new things, that they understand, and of course, they understand in terms of the programming language. It's also on the legal side that it would be very difficult to alter or to modify the terms of a smart contract after it has been accepted. Now let's look at public verifiability. Anyone can look at the contract, the smart contract. So as we mentioned, one of the beauties and also one of the risks of blockchain is that it is transparent. So whatever smart contract is embedded in an NFT or a token, that is public knowledge on public blockchains. As of now, they typically are. I wouldn't be surprised if in a number of years there's a technology developed where you can hide smart contracts. The question would become whether or not that is legally viable and whether that is something that people essentially would agree to in the greater space of Web3. Okay, because all of these features about smart contracts, they simply boost trust, they boost credibility, and they make it much more accountable for if there's any harm done in the series of transactions. It can be traced back. Let's talk now about trustless operations. This is probably one of the biggest benefits of smart contracts in terms of the manufacturing, logistics, medical, healthcare, any industry. Everyone wants to have trustless operations. Trustless operations essentially mean that an operation can be performed and it does not need to be verified. It does not need to be verified because it is verified by design. And when we first talked about smart contracts and blockchain rather, we talked about this quality of the blockchain, that the blockchain is immutable. So that means that once data is entered and once a transaction occurs, that data cannot be changed. So let's think about cases where we rely on third parties or intermediaries to verify information. One of my favorite use cases is in international trade. And usually in international trade deals, we have a buyer, a seller, and then we have the bank. And the banks, and this is a very simplified deal, but the bank's role is to verify once shipment has been received or shipped, and also once payment has been sent or received, right? And so they are, in all intents and purposes, a verifier, right? They do sometimes provide loans or letters of credit, but in some cases, the bank is simply receiving money and holding on to it until they can verify that a shipment of goods has been received. So in the world of blockchain, if we have logistics or international trade that's on a blockchain, it can be a private blockchain as well. But by removing the intermediary of the bank, by removing that role, and simply relying upon the data which is provided in the blockchain to verify when something has been received and when something has been sent, that saves time. It certainly saves money. It increases the credibility and the trust in the transaction, and it reduces the risk. And so for all of these reasons, smart contracts are really sort of the engine that the blockchain is running on. The blockchain itself, in terms of that technology, it is great. But when we want to look at use cases, when we want to look at how businesses will implement this technology, we really start to focus in on smart contracts. And so these transactions that can be trustless can be seen in corporate spaces, but they can even be seen in peer-to-peer transactions. Let's take, for example, babysitters, one of my favorite transactions. So if you have a babysitter that is to come to your house and to watch your children, essentially that person will arrive, they will do the job, watch the children, and then they will leave. Once you return home, you will pay them. But let's say there's something going on where maybe you don't have money at the time, or usually babysitters take cash. And so you need to provide payment to this person only upon the condition that you're satisfied with their work. I could think of a number of technologies that could facilitate the payment to babysitters once they're finished watching children, right? We can think of technologies such as cameras that we have in our home, right? That could detect when the job is done and then release the payment, all trustless. And so that is just a very far-fetched example. But the point I'm trying to make is that smart contracts really are the bread and butter of the blockchain. They really are the backbone of the businesses that will be using blockchain technology to make people's lives easier.